Chapter 3, Section 3 is about exponential growth. We're going to use it for applications. Exponential growth model is c times e to the kx power, where k is your rate of growth. If you take the derivative of that, it would be c times e to the kx times the derivative of the exponent, which would be k. So that's what this is here, and then since it's c times e to the kx, that's the original function. So the derivative ends up being k times the original function. When we use this, we're going to substitute and we're going to use p of t is equal to p sub o e to the kt power. So p sub o is our initial amount, and p of t is our ending amount, and it is going to be some function of time. T is going to be time. So again, k has to be greater than 0 because we're talking about growing here. So we're going to be multiplying. If k were negative, we'd be dividing, and that would make something smaller. So our formula for doubling is t is equal to the natural log of 2 over k. So if you take the p of t is equal to p sub o e to the kt power, and you replace the ending amount with 2 and the beginning amount with 1 and solve this for t, in order to do that, you would have to take the natural log of both sides. So it would be ln t is equal to ln e to the kt power, because 1 times anything is itself. So then this kt is going to come out front, and ln e is just 1. So we end up with ln 2 is equal to kt divided by k, and you end up with this formula. So Pete Zaz Incorporated is selling franchises for pizza shops throughout the country. The marketing manager estimates that the number of franchise N will increase at a rate of 10% per year. So we've got a k here of 0.10, and the derivative then is just going to be 0.10 times our function. So find the function that satisfies the equation. Assume the number of franchises at time 0 is 50. So this is going to be your p sub o. This is your initial amount. So if we're just following our formula, then our p of t will be equal to our initial amount, which is 50, e to the rate of growth k, which is 0.10, t. Okay, so there's our function. How many franchises will there be in 20 years? So t is equal to 20. So p of 20 will equal 50 e to the 0.10 times 20. And this is approximately, when you put it in your calculator, 369. In what period number of 50
franchises double? So you have the formula. Your formula is t is equal to ln 2 over k. So then t will be equal to ln 2 over 0.10, which is approximately 6.9 years. So if we're just asking when something's going to double, it doesn't really matter how many we started out with. We're always going to end up with twice as much. So 50 turned into 100, or 100 would turn into 200, etc. Note that the formula for compounding continuously is an exponential growth formula. So you've seen this one a few times. A is equal to p e to the rt power. So your principal times e raised to the rate times time is equal to your ending amount. Hardy Bank advertises that it compounds interest continuously and that it will double your money in 12 years. What is the annual interest rate? Okay, so it's doubling our money. So it's going to be t is equal to ln 2 over r, and this time they gave us time of 12. 12 is equal to ln 2 over r. If we multiply both sides by r and divide both sides by 12, this becomes r is equal to ln 2 over 12, which is approximately 5.8%. Okay, the Consumer Price Index compares the cost C of goods and services of various years, where 1983 is used as the base. So 1983 is time 0. The same goods and services that cost $100 in 1983 cost $226 in 2012. So let's figure out first of all what T is. 2012 minus 1983 is going to give us 29 years. Okay. Model C as an exponential function rounding the growth rate k to 5 decimal places. All right. So C of t will be equal to 100 e to the kt power. So then, what do we have here? We have an ending amount of 226, an initial amount of 100, and a time of 29. So our ending amount is 226. Beginning amount's 100. E raised to the k times 29. All right, so in order to set up my whole formula, I'm going to need that rate. So let's go ahead and solve this. Let's divide both sides by 100. So 226 over 100 is equal to e to the 29k. We'll take the natural log of both sides. So natural log of 226 over 100 is equal to, when I take the natural log of the right-hand side, it just becomes 29k. K will be equal to natural log of 226 divided by 100, all divided by 29, which is equal to approximately 0.02812. So then RC of t will be equal to 100 e to the 0.02812 t for our function. So estimate what the goods and services costing $100 in 1983 will cost in the year 2020. All right, so 2020 minus 1983, it's what, 37 years? So then 4 times t, we will be 100 e to the 0.02812 times 37, which is approximately $283. In what year did the same goods and services cost twice the 1983 price? So again, we've got that nice formula. T is going to be equal to natural log of 2 divided by r. So that's going to be natural log of 2 divided by 0.02812, which is approximately 24.6 years. So then it will happen in that 24th year. So we're starting at 1983 plus the 24th year. That's going to give us 2007. In the year 2007, the cost of goods and services will have doubled.